All right, we're back. We're on page 8 of notes 14 of Calc AB. We're doing or approximating definite integrals using Riemann sums, using trapezoidal sums, using whatever it asks for. So let's see. It says approximate the integral from 0 to 4 of f of x dx, where f of x is 2x plus 3, using 4 partitions and a right Riemann sum, 3 and a left, 3 and a trapezoid, 6 and a trapezoid. So I think that 2 of these answers are going to be exactly the same, and I think they're going to be the exact answer. So let's get started and see, do we need to draw it, I guess is the question. Like, I feel like I don't need to draw it because I think, like, all right, so I'm not going to start out drawing it. I will end up drawing it because I always overdo it. But I think that all I really need is I need delta x, which is like the base of this thing. And we're going from 0 to 4, so 4 minus 0, and we're going to divide it by 4. So each of them has a height of 1, a base along the x-axis. And then we're doing a right Riemann sum. So like if you think about it, and this is, I definitely prefer to do these without having to draw. So like I would encourage you to get in the spirit of this. A right Riemann sum, like we're gonna find a height here, 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 and here. So what we're doing is we're gonna end up saying that the integral from 0 to 4 of f of x dx. Now one thing, the reason that for AP in particular, we do these like by hand and we write them out is that you do such small numbers, even on the AP exam, that like you can always just write it out by hand. I think the most you would ever do is like 5 maybe, I don't know. So this will be 1 and then times f of 1 plus, you know what, they're all 1. So f of 2, f of 3, f of 4. And we'll save that for the calculator, but we could also say, am I using n? No, I'm going to use I. If you're in AP, you should try to use K, because they always use K. I just like can't make myself do it. I learned it, I guess, one way, and like that's the way it's going to stay. This will work. All right, 3 partitions. So for 3 partitions, delta x, so 3 partitions, 3 subintervals, 3 rectangles, that's all basically the same thing. 4 minus 0 divided by 3, which is 4/3. Okay, so where are you going to find your heights? Yeah, there. So this is 0, this is 4. You don't really need to draw this, but we're doing 3, right? So 4/3, 8/3, and then 12/3 gets you to 4. So it's going to be the integral from 0 to 4 of f of x dx. So approximately, so 4/3 is b minus a divided by n, 4 minus 0 divided by n, and then f of 4/3, f of 8/3, and then f of 12/3, or 4 if you prefer. And then can we write that as a summation? We definitely can. From 1 to 3, 4/3 is each of their bases, and then f of, so it's really 0 plus 4/3 times I, but I'm just going to write 4/3 times I because 0 plus that is the same. We'll use a calculator in a second. All right. I feel pretty passionately that this part C and D are going to give us the same answer, and it's the correct answer. The reason I feel that is that this function on the interval from 0 to 4, I think just gives you a trapezoid, right? So it's 2x plus 3. So if we do 2x plus 3, so if this is 0 and this is 4, 2x plus 3 is just going to be 3. That's not, I do not believe that that's vertical. Maybe it was. That's vertical. So that's 3, and then 2x plus 3 is 8 plus 3 is 11. And so, I mean, it's a line. So if I do 3 partitions, here, here, I'm going to be adding this trapezoid, which perfectly gives you, really? What is this? Is that, oh, what's wrong with my eyes? I don't feel like that's vertical. It looks more vertical on the computer screen than it does on my iPad. I'm a brain. Okay, well, anyway, each of these is just going to, it's going to work. 4/3, 8/3. So we can write it as we should because that's what it's asking us to do. But I'm telling you, it's not approximate, it's equal. So it's going to be 1/2, then 4/3, then we're going to do f of 0 plus 2, f of 4/3. I got confused for a second. 2, f of 8/3. It takes so much writing to write this, plus just one of these, f of 4. It's going to be exactly that. 6 partitions, 1,000,000 partitions. As long as you're doing trapezoids, 1 partition, it's going to give you the exact same answer, but we're going to do it anyway. So what are we doing here? What's the easiest way to do this? I guess I'll do this. 0, 4. So it's like 4 divided by 6, which is 2/3. I think I should count by 2/3. So what do I need 6. What's the best way to get 6? I guess here, 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 here. 2/3, 4/3, 6/3, 8/3, 10/3, and 12/3. This is really annoying when you know that it's the same. F of x dx equals, not an approximation. 1/2, 2/3, and then here we go. It's f of 0 plus 2, f of 2/3, 2f of 4/3, 2f of 6/3. Oh god. Let's do like a line break. Plus 2f of 8/3. This is annoying. 2f of. So you ever wonder if your teacher also finds boring, repetitive things annoying? Yes, they do. I'm going to speak for all teachers. Yeah, we do. Still got to do them. And actually, whenever my students are complaining about how boring and annoying something is, I always think like, yeah, you only have to do it once. I have to do it every time my class meets, like forever. So yeah, don't talk to me about that, basically. All right, what are we doing? Calculator stuff, I guess. I'll do all these on the calculator, and then I'll cut this page into 2 videos, I suppose. All right, new whatever. F of x is 2x plus 3. We're going to do f of, should I do the summation? I don't actually, the summation might not actually be faster in this case. Well, maybe it is. F of I. 32. So that's the first answer, equals 32. The next one is, the one thing that is a little faster is updating it, I guess. So 4/3, and then I times 4/3, 33.33. I bet that's really close. 33.333. I mean, because that's like clearly a third. And then, I mean, is that close enough? Probably. I don't know why that would be. All right, trapezoids. So for the trapezoid, I should just be able to do 1/2, and then the full trapezoid, 4, and then 11 plus 3 is 14. So I think I'm going to get 28 no matter what I type in for this. So 1/2, 4/3, f of 0 plus 2 times, I don't need times, f of 4/3 plus 2f of 8/3 plus only f of 12/3, which is 3, which, wait, what? 1/2, 4, 3 plus 11. 1/2, 4, 3 plus 11. 1/2, 4, 3 plus 11. So this didn't give me the same answer. You know what it did give me though? I don't know. Did I do something wrong? 0, blah, blah, blah. 1/2, 4/3. F of 0. 2 of those. 2 of those. 1 of the f of 4. Come on now. Okay. Disaster or something averted. So we got 28. We're gonna get 28 for the next one. I'm gonna type it in, but like it's gonna happen. So here we go. Let's get it again in a weirder way. Let's try to get it right this time. Not that you got it wrong, but like we're all in this together, right? 2, f of 2/3, 2f of 4/3, plus 2f of 6/3. It's so much typing. 2f. I should have written a summation for this. It's just like the summation's a little weird, and I don't feel like it's super educational to like see it. 12/3 is 4/28. There we go. So trapezoidal sum on a trapezoid is obviously going to, it's like using a rectangle sum on a rectangle. Like you're going to get the exact value. So we got it both times. I'm going to go back. Should we find, oh, we found the exact value, right? Because the exact thing, so we could do this. Integral f of x, 0 to 4. Also 28, because it's getting the exact value when it does the trapezoid. So more confirmation, like it's always worth confirming, but like it's just the same thing. All right. I'll come back in the next video and do the next problem, which it's also kind of going to be a trapezoid, so it's going to be really similar, but this video is probably already really long, so I'll be back in the next one, and I will see you there.